Okay, so I will talk about compiling and linking with libraries. And here I will say some more about the compilers at HPC2N and how to load the compiler toolchains, how to use the compilers, and some popular flags. And of course, also how to link with libraries, or rather how to find out how to link with libraries. This very much goes together with the previous section about the module system, but the installed compilers are for Fortran 77, 90, and 95, and C and C++. There are also other compilers like Clang, but you can check that out when you do module spider. And in order to load the compilers, you need a compiler suite, possibly with libraries, depending on what you need, as I just showed you. All the compiler toolchains are available to load directly, so you can see them with MLAV. You see here, you also see that there are some other things that can be loaded directly, like MATLAB and Nextflow. But in general, it is compilers. So let's try loading a newer version of FUS. And I will try to do that, and you could also do so if you want to. And then I will do module list. And I need to spell right, like that. And here you see this is the module itself. And there are various things. There's GCC, and there is hardware location thingy. There is OpenMPI, OpenBLAS, FlexiBLAS, fast Fourier transformation, scalar pack, many things loaded with that one. And you can see here in the example there, I used ML, and that is the same as module list. It is simply short for that. So you can see you get the same output. So what if you wanted to compile with OpenMP? Well, all compilers already has this included, so it's enough to load the module and then add the appropriate flag. Note that if you do not name the executable when you compile, then it will be named a.out as default. And that means that next time you compile something, that executable will also be named a.out and overwrite it. So it's always a good idea to name it. So you do that with -o and whatever name you want to use. I have, because I found it easy, just used the same name of the program. So if it's called hello.c, I call the executable hello. So that is how I have done it. And if you do it differently, you have to make changes to the submit scripts, but I will look at that in just a short moment. So if you compile with GCC, then you can see here what are the names of the compilers. And the MPI compilers are named like this. Didn't I list? I didn't. Okay. But I talk about it in the example. So let's try and compile a C program. And to do that, I'm going to go into the directory for the exercises. So I will change to the project directory. I did this, and it's called intro HPC2N, like that. And you can see I have here the one I previously cloned, intro course. And again, there is a directory called exercises here. So I will go to that. I start typing the name and then I press tab. And if there are no other that fits it, it will autocomplete to that. And that's an easy way to write it fast. And here we have all the various directories, mainly for the application examples, but I will go into the one called simple, because that's where I have the exercises that I have made for this course here. And let's try to compile hello.c. Let's see, do I have anything loaded? Yes, I have FOSS 2023 loaded, but I needed 2022 for the if I want to run it with the submit script without changing it. So I am going to do ml purge. And now I have nothing loaded. I'm going to load FOSS 2022b because that's the one I used in the submit script. I am now using ml as short for module. And you can see it's loaded. I'm going to do gcc hello.c. And then I am outputting it into a file called hello. And doing so created this file. And it has a star, which means that it's executable. Hello.c should not be executable, but I probably changed it with chmod for some reason to test something. But hello is now executable, and you can run it with ./hello. I think I'm going to make this slightly wider because it is a very long path. And doing so will make it run. Of course, you shouldn't usually run things on the command line here on the login node because everyone shares the login node. And if you're running a lot of long and heavy stuff, then other people will get a slow login node. But for these kind of very short programs, there is no problem. So you can do that. So you should try do this. And you should also try compiling an MPI program. And that you can do immediately because with FOSS, there was already a MPI compiler loaded, or MPI library. So we do MPI CC. And then I have a program called MPI hello.c that I'm going to compile. And then I am naming that MPI hello. And it's here now. You can run that with MPI run MPI hello. And you can see there's 28 cores on the login node. And each one of them returns hello world. If you run it again, you will most likely see that the order is random because you cannot tell which one of the processors that will return first because they may be running something else or whatever. So it's whichever one finishes it first will report. Note that if you later load a different compiler than the one your program was compiled with, you should recompile your program before running it. It may work, it may not, but it's a good idea to, but if you recompile it, it definitely will work. So now try doing the same thing, but with FOSS 2023b. And you could also see what happens if you then load. I will try and unload this module touch. And then I'm going to load Intel. And then I will try run my program and see if it works. It doesn't, as you can see, because now it cannot find the library because it's now pointing to a different MPI libraries are now pointing to the one for the Intel, which was a different one than the one you compiled with. So you will purge this. We can also just recompile it. Let's see. It's probably MPI CXX. That is compiling it, and MPI hello C, and MPI hello Intel. Okay. What's it called? There is an extra I when it's Intel's. Okay, that. Sorry. Like this. Now it compiled it. And it's there. And now we should be able to run it. And we can't. I wonder why. Anyway, you need to be able to run it with the same, when you have the same compiler loaded that you actually compiled it with. I will look into this in a moment, but I'll just continue for now. So let's try look at an OpenMP program instead. And I'm going to module purge here. And module load FOSS to B. And then I will compile this one. And if you're doing GCC, you need to say -f OpenMP in order to compile with the OpenMP library. So the file is called that, and then I want the output to be named the same. And now let's try run it. And there is one thread. I would like more. So I will export OMP num threads equals 4. And then run it again. And now it says number of threads of 4. So that is something you could try also. And you could try rerun it with different values, but it does the same for each one of them. And you can also try with different tool chains. So. And this is the names of the compilers for Intel, which was the one I was using, so I don't know. But let's, try it again and try run it and see what happens. And I just want to also go through this and talk about the flags and the linking, and then I will give you a few minutes to try these things out yourself. So there are some commonly used flags that you may want to use. And you can have the one they call -fast. It optimizes speed, and these are flags to the compilers. -g gives debug information, and you need to use that if you are going to debug it later with a some sort of debugger. And you also can compile with various types of optimization. And you can go -0, which is no optimizations, or -0, which is the same as -02. That is the default that is optimized for code speed. And that's what we generally recommend you do. -01 optimizes to favor code size and code locality, but disables loop unrolling. And in some cases, that is advantageous, but it varies a little bit, and you may have to test it on your code to see what is best. -03 can also be good, but there's actually programs where it doesn't enable performance, and it can even slow it down. And if the code is badly written, it may even fail when you use 03 optimizations. But it does more loop and memory access transformations and prefetching. So you can also just enable speed optimizations. And here for Intel, it's -Q OpenMP, where for GCC, it's -F OpenMP. So, okay, you are compiling your program, but you may also want to link with something like LayPack or other things. So the build environment, you are actually loading, if you're loading something like FOSS or Intel, you're getting all the libraries access to them as well. But you may also want to be able to link to these libraries. And in order to do that, you can use a tool, something that's called build env. And if you do that, it's actually, unfortunately, not installed for all the compiler tool chains right now. But ask for it, and we will install it for them. I'm not sure it's installed even for 2021B, but I will check. It's not. I think it's for 2021 though. Yes, it was. And then you can do ml show build env, and then you will get all these environmental variables that you can use. For instance, if you wanted to compile with LayPack, then you can go in here and see that you would have to add these two flags. Or if you have loaded this build env, then you can use this environmental variable instead. And you do that with a $sign liblaypack. And the good thing about that is that it will work even if you later use a different compiler, whereas these may be named differently. So that is a very good way of finding out how to link with something. And yeah, there's the same example here. And on this page here, there is a lot about the libraries that are installed at Kebnekaise and how you link with them. So in order to compile a program, first load a compiler toolchain. And there are GCC and Intel compilers. And then to compile, you can compile MPI programs when you have loaded a compiler toolchain that has MPI libraries like FOSS or Intel. And ml show build env is the easiest way to see how to link with a library. And if build env is not installed for the compiler toolchain that you want to use, ask us to install it. Let's take 5 minutes to let people play around with the compilers a little bit and see how it works.